this video, we're going to talk about the addition rules of probability. And there are going to be several things that we need to discuss first. One of those is what we consider mutually exclusive events. Mutually exclusive events are events that cannot occur at the same time. So these are things that are not going to be occurring at the same time. What I mean by that is such as an outcome drawing a card and rolling a die. They're not going to occur at the exact same time. It's also considered where there's no outcomes that are common. No outcomes that are common. And so these are considered mutually exclusive. And we're going to look at some examples of how things can be mutually exclusive or dependent or anything like that. So let's first think of some what we consider examples of mutually exclusive events. The first one is political party affiliations. And political party affiliations, here you're either Republican, Democrat, Independent, things like that. If you identify yourself with a political party, you're one or the other. You don't run with both. Think about the Senate, the House of Representatives, even the President. He has to determine, he or she must determine which party he's going to be affiliated with. It has to be the Republican or a Democrat or Independent, or now we have the Tea Party. And so these are mutually exclusive. They can't run underneath the Republican and the Democrat. Now he may have the same views as both, but he cannot run underneath both party affiliations. Another example is blood type. And I can bet you're already thinking, well, yeah, there's some things that can overlap there. Blood type comes in 4 different types. There's A, there's B, there's AB, and there's O. Now O is a universal donor, and it can go into the other ones, but it's not the ideal if you're wanting to get a transfusion. But you're either A, B, AB, or you're O. You don't fall under both types of categories. Another mutually exclusive event is the color of card, where we're talking about in a deck of cards. Here it's either red or black. Now under the reds you have the hearts and you have the diamonds. Under the blacks you have the spades and you have the clubs. But whenever you draw a card, you know immediately it's either going to be red or it's going to be black. So these are some basic examples of mutually exclusive events. You're either in one or the other. So now then, when we're talking about this, when events occur and they're mutually exclusive, the probability that A or B, and this is going to be a key thing, this word or, that A or B occurs is going to be this formula. The probability that A or B occurs, ooh, that's a bad B. Let me go back and redo that B, please. A or B is going to be the probability of A plus the probability of B. Anytime that you're wanting one thing or another to happen, you're going to add their probabilities. Now I want to caution you, this is for mutually exclusive, that we're strictly going to add the two items. We'll come to things in a moment where they're not mutually exclusive and we have to do a little bit more to the formula. But this is if they're mutually exclusive, we just add the two. So let's look at an example. When rolling one die, what is the probability of getting a 3 or a 5? Okay, let's think about rolling a die. Remember, we have the possible outcomes of 1, 2, 3, 4, 5, or 6. Their probability is each 1/6. So, when I want the probability of getting a 3 or a 5, can I ever get a 3 and a 5 at the same time? No. So that's what makes these mutually exclusive, meaning they can't happen at the same time. Since they can't happen at the same time, this is going to be the probability of getting a 3 plus the probability of getting a 5. Probability of getting a 3 is 1/6. Probability of getting a 5 is also 1/6. When I add those, that gives me 2/6. Remember what I said previously, when we are looking at probabilities, we either want to put them into simplified form or into decimals. When I simplify this, I'm going to get 1/3, which is equal to 0.333. So the probability of getting a 3 or a 5 when rolling one die is equal to 1/3, or 1/3. Again, these are when things are mutually exclusive. But not all events are mutually exclusive. Think about a deck of cards. We've already discussed that in a deck of cards you have black cards, so these are going to be the black cards, and you have red cards. And so these are the red cards. A card cannot be in red and black at the same time, so these are considered mutually exclusive. And I can't spell that again. Let's try that again. So these are mutually exclusive because they cannot be a red and a black at the same time. Now, let's look at another example. Okay. The probability of getting kings and black cards. Okay, so here are the black cards again. And this time, here are the kings, because remember I have 2 red kings and I have 2 black kings. So these two things overlap. They're not mutually exclusive, because a king can be a black card also, and a black card can be a king. So these are not mutually exclusive, because I can be in both circles at the same time. If I happen to draw a black king, I've got to go into both circles, which makes it a little bit difficult. And it changes how we do our calculations when we're looking at them. Mutually exclusive, this one, remember, probability of A or B. so this one's the probability of A or B happening, is strictly the probability of A plus the probability of B. Now let's look at what goes on whenever they're not mutually exclusive. So if A and B are not mutually exclusive, key word there, not mutually exclusive, and then the probability that A or, and I'm still looking at that word or, B will occur is equal to the probability of A or B equals the probability of A plus the probability of B, just like we did before, but this time we have to subtract out the probability of A and B happening. The reason why is because if you're here and you're here, you've already been counted here, then you get counted here again, so we've got to cut you out one time. Okay, we've got to cut out the overlap because you've been counted twice. So we've got to cut you out one time. And this will become a little bit more evident whenever we're looking at some examples, but what we're talking about is something has been counted in this probability and it has been counted in this one. So we've got to take it out, but otherwise it gets counted twice. So let's look at an example. What is the probability of drawing a king or a black card? Okay, we looked at the picture a few moments ago. Now, it's the probability of a king or a black. And we said that these were not mutually exclusive because I could be a black king. So let's think about our kings for a moment. I could have the king of clubs. I could have the king of spades. I could have the king of diamonds. I could have the king of hearts. Okay. Of my black cards, I've got all of the clubs and all of the spades. So whenever we do our calculation, it's the probability of being a king plus the probability of being a black card minus the probability of being a black king. Because being a king includes all four of these, whether you're red or black. And therefore that is going to be 4 out of 52. Being a black card includes all 26, that's 13 from the clubs, 13 from the spades, out of 52. Therefore, these two kings have actually been counted here and here, because I've been counted as a king and I've been counted as a black card. I don't want to count them as, I can't count them as both. That's not legal. So I need to subtract them out, and I have 2 black kings, which will help offset and take away where I've counted them twice. So now I'm looking at 4 plus 26, that's 30, minus 2, that's going to be 28 out of 52. And we need to simplify that. So that's going to be 14 out of 52, which is the same thing as, oh, not 14 out of 52, that would be 14 out of 26. So that's 7 out of 13. So I have 7 out of 13 cards that are, or the probability of getting a king or a black card is 7 out of 13. We do have to be very careful about making sure that we do this subtracting of what has been counted twice. Again, I told you that the or was extremely important. When you're asked for the probability of one event or another event, make sure that you use addition. The and is going to represent something else, but I'm wanting one thing or another, so I'm wanting them both, and that's why it's an addition type problem. If you have questions, please come see me.